Welcome. This is the Department of Physics and Astronomy at the University of Manitoba. How do you know if you're a physicist or not? Whether you want to study physics. Here's some questions you can ask yourself. Why is the sky blue? It's a very good physics question. Another one, boomerangs, throw them and they come back. How does that work? Why do they come back? As a student, you would go through numerous programs which expose you to different aspects of that, all on the way to understanding the core ideas of the science which underlies and unifies all of these different processes we're surrounded with.
Our department has some really strong researchers in all the main areas. So we have subatomic physics, condensed matter physics, astrophysics, medical physics. I am involved with what we call subatomic physics. Sometimes you can call it particle and nuclear physics. Our goal is that we're trying to keep zooming in onto nature and identify really the most fundamental building blocks of matter.
In the department here, we're involved in a lot of different subatomic physics experiments. So the subatomic physics traditionally is divided in theoretical and experimental subatomic physics. On the experimental side, we typically collaborate with other universities. There's only so many particle accelerators in the world, and so we collaborate in large groups nationally and internationally on these large accelerator projects. Typically they involve anywhere from 100 up to 1,000 people collaborating together.
Condensed matter actually has a lot of everything. It's mostly like chemistry and physics together. The professors do a much more hands-on learning experience, and you really get to understand the stuff that you don't understand because the profs usually check in on you more often.
Condensed matter physics is a really cool field of research because it allows for this neat blend between theoretical and experimental work. Something else that's really cool about condensed matter research is it's very accessible to students. I started research in my first year on some very basic systems, this pendulum system, and now my work building off of that has become significant to other researchers in the condensed matter field.
is an astounding place to pursue a career in astronomy. Professors here are working on everything from the radio astronomy on one end of the electromagnetic spectrum, all the way up to X-rays and gamma rays on the other. If you want to get involved in some of the most groundbreaking international astronomy projects taking place around the world, is the place to be.
I teach in first year labs where we do experiments and we have some hands-on practice with applying and testing the theories that students are learning in class. And there are lots of opportunities for physics and astronomy students to volunteer and sharing the love of physics and astronomy. I teach a couple observational astronomy classes where students use telescopes and learn how to go from taking a beautiful image with telescopes to doing science with those images.
You provide students with a rich training environment that offers vital research and educational experience in medical and biophysics. Students expect to receive exposure to extensive interdisciplinary training, providing them with problem solving and other diverse skills.
For my system, I am minimizing the size, weight, and cost of a portable microwave system, and I'm able to achieve this design through 3D printing in the makerspace.
I designed breast phantoms, which we use now to simulate the breast when testing our systems before proceeding to testing on actual patients. We needed to be able to 3D print these files because they were of complex shape.
There's a myriad of things that I learned and completely came away with a sophisticated understanding of, and other things are introduced and you're evolving your understanding of things.
What you learn when you study physics is how to solve a problem that you've never seen before. This is a research university. It's part of the U15 in Canada. And we have some of the world's experts in different areas, as some of them have some really fantastic laboratories.
Within Canada, we work at Triumph, which is Canada's particle accelerator lab in Vancouver. We have in particular one faculty member who does pretty much all of his research there. That's Professor Gerald Gwynner. So as a student, you're typically also involved in a snapshot in time, a slice in time if you wish. You're either involved in the design aspects, you're involved in the prototyping, you're involved in the commissioning, or you're involved in the data taking itself. So you get sort of that multifaceted experience, which then makes you a well-rounded scientist.
I conduct research in experimental particle physics. I'm involved with a particle collider in Japan called the Bell 2 experiment. There we're colliding beams of matter and antimatter to search for new particles such as dark matter. The nature of dark matter is one of the biggest mysteries in physics today, and if it is produced by the collider, it would be very rare, so we search for a large number of collisions. Our group is also locally developing new technologies for detecting particles. This is an excellent research area for students interested in solving challenging problems while working as a part of a large international team.
I am the president of the Organization of Physics Undergraduate Students. Within OPUS, I extend my contribution by providing complimentary weekly tutoring sessions to aid first-year students in acclimating to the fast-paced learning environment university provides.
OPUS has a lot to offer, whether that's tutoring for first-year physics courses and many events throughout the year where you can get involved with the department and fellow undergraduate students. The department has a lot of opportunities to get involved. Summer research, where you can gain practical experience doing research in your field of study.
I'm part of one of the groups working here at the University of Manitoba working on the Molar experiment, and my area of specialties are pixel detectors for high energy physics. The sensors we work with detects charged particles, electrons. So the Molar experiment is measuring some physics due to what we call the weak interaction. It's parity violating asymmetry, to be specific. For anyone to pursue subatomic physics at U of M, because it's pretty diverse. There's a lot of people doing work in a lot of different fields or subfields in subatomic physics. The Molar experiment will take place in Jefferson Lab, which is in Virginia of the United States, and it's trying to measure how, when you make small changes to some properties of electrons, the behavior or their behavior changes, and we're trying to measure that to very, very precise values.
The employment rate for physicists, based on statistics that have been gathered, is about 98% employment. The majority of people who are employed may go into things like engineering or technical firm, finance. They do predicting. Others will go into developing new medical devices or new techniques.
We partner closely with the National Research Council of Canada, Natural Resources Canada, and the Canadian Space Agency, as well as major leading Canadian space industrial companies that are building state-of-the-art instrumentation, the spacefaring civilization that we are becoming. And it's all happening right here in Canada, and UM is leading the way.
The department has constructed a remote observatory. So we have a brand new telescope that will be operable from anywhere in the city or anywhere in the world, as long as people have an internet connection.
The department has a long-standing history of accreditation, delivering consistently high-quality education. Within medical physics, we offer ample opportunities to be involved in exciting and award-winning research, enhanced by our affiliation with Cancer Care Manitoba, giving students access to state-of-the-art medical equipment.
The faculty and the department isn't just teaching people physics. You know, of course, you're in courses learning physics, but also more broadly training people to be physicists.
We welcome students O levels to join us for our research program. Students will be exposed to knowledge and skill set in physics, engineering, biology, and medicine.
As a woman in physics here, it was lovely to come here. It was very comfortable being a woman here in terms of our colleagues. They were very happy to pat us on the back when we did well and acknowledge us.
We are a diverse team. We do modeling, we do simulations, we do observations, and I try to help the next generation who are also equally passionate to pursue that passion and not be afraid. Out of physics degree, you can actually have tons of opportunities.
I'm dedicated to improving equity, diversity, and inclusion in physics, and particularly for women and gender diverse individuals, as well as to improve Indigenous contributions and success in science, particularly physics.
When you let different people create different music, then you get things like rock and roll and jazz. That's what makes physics alive. That's what this attitude, this bringing things together from different perspectives. So it's for everybody. In fact, we must absolutely have everybody.